Okay, today we're starting a new unit, Unit 15. It's on solving systems of equations. 15.1 is solving systems of equations with two linear equations. Okay, so a system of equations is two or more equations with the same variables. The solution to a system of equations with two variables is an ordered pair x, y. Okay, linear systems can have one solution, no solution, or infinitely many solutions. If a linear system has one solution, the answer looks like x comma y. If a solution has no solution or infinitely many solutions, the answer is just no solution or infinitely many solutions. Okay? Now there's three ways to solve a system of equations. The first way is solving it graphically. Okay? Solving it graphically, we put both equations into slope-intercept form, which looks like y equals mx plus b. Plus b. Then we graph both of those lines and we look for the point where they intersect or where they meet up with each other. Okay? So I'm going to solve example one just by graphing this. I'm going to put both of these equations in slope-intercept form. So to get this first equation in slope-intercept form, I have to subtract that 3x from both sides. It's going to look like negative y is equal to negative 3x minus 5. It's not yet in slope-intercept form because of this negative number. So I have to divide everything by a negative 1 to get y all by itself. So I'll end up with y equals 3x plus 5. Okay, now that is in slope-intercept form. And for the second line here, got to get this also into slope-intercept form. And I'll do that by subtracting my 4x to both sides there. If I subtract 4x on both sides, I'll end up with y is equal to a negative 4x minus 2. Okay, now that both of my equations are in slope-intercept form, I'm going to put them on my graph here. Starting with the blue equation, y equals 3x plus 5. I'm going to go up to 5. 1, 2, 3, 4, 5. So that's my y-intercept. And now my slope is 3x. So I rise 3, 1, 2, 3, and go over to the right 1. Okay? And now I'm out of room up in this area, but I can do this backwards. I can go down 3, 1, 2, 3, and to the left 1. And we don't have to do this many points, but the more points you do, the easier it is to draw your line. And the straighter our line is, the better, because we're going to be looking at where these points intersect, and we want it to be as good as we possibly can get it. Okay? Now, for the second line, negative 4x minus 2. So my y-intercept is negative 2. So put a dot down here at negative 2. And my slope is negative 4x. So I go down 4, 1, 2, 3, 4, and over 1. Same thing, or I can do it backwards. And that's going to be my line right here. It's going to start here and go through all of these points and fix that. Okay. Now, my answer is always going to be where these 2 points meet. If I'm looking, it's going to be right here at this point, okay? And that point is at negative 1, 2. So my solution is going to be negative 1, 2 as an ordered pair. Okay. Looking at example 2 here, got to do the same thing. I got to put both of these equations in standard form. Okay, so this first equation, I'm going to subtract my 3x from both sides. So I'm giving negative 3x minus 15. Then I have to divide everything by negative 3 to get y all by itself. It's going to give me x minus, or plus, excuse me, x plus 5. Then for the second equation, I'm just going to subtract that x on both sides and then divide everything by negative. So we'll end up with, let me do this in red, we'll end up with y is equal to x minus 2. There's those two equations written in in slope-intercept form. So now graphing this blue equation, my y-intercept is 5, so I'll go up to 5. and then my slope is 1, so I'm going to go up 1 over 1 all the way across. So my line is going to look like this. Okay. And then graphing the red line here, my y-intercept is -2. And again, I have a slope of 1, so it's going to look like it's here. Fix that so it hits those points. There we go. Okay, now if I graph these correctly, these two lines are going to go on forever, and they're never going to touch each other. Okay, so what that means is there's no solution to this answer because they never cross. Okay, so I'll put no solution, and that's going to be the answer to this graph, or this system of equations. Now, the only other case that we could have on the graph is when I plot my first line, I end up with my second line right on top of that first line. In that case, every single point is an intersection, or in other words, we have infinitely many solutions. So that's what that infinitely many solutions would look like. It's just one straight line, they overlap each other. Okay? So that's the first way to solve these. The second way is using the substitution method. Okay? Using the substitution method, we solve one equation for a variable to be all by itself, and then we plug that equation into the other equation. Okay, so what that looks like is I'm going to change this first equation, and I'm going to get x all by itself. You can get x or y all by itself, whatever's easiest. But it's easiest to get x by itself, so I'm going to add 5y to both sides. That's going to make this x equals 5y plus 13. Okay? Now, I'm going to take this equation, and I'm going to plug it into my second equation. So in other words, I'm going to rewrite this second equation, -7 times x, but instead of putting x there, I'm going to put what x is equal. X is equal to 5y plus 13. So 5y plus 13 plus 8y is equal to -10. Now I have an equation with only one variable, and we've been solving these for a long time, so now I know how to solve this. I'm going to distribute this 7 as my first step. -7 times 5y is -35y, and -7 times 13 is -91, and we still have plus 8y, and that's equal to -10. I'm going to combine my like terms. I've got a -35y and an 8y. That's going to combine into a -27y. And then I've still got that -91 is equal to -10. I'm going to add 91 to both sides. End up with -27y is equal to 81. Then my last step would be to divide both sides by -27. That would give me y is equal to -3. Okay, so now I've solved for y, but remember I need an x and a y. So now I take what I know y is, -3, and I can plug it in to any of these equations up top here. Okay, so if y equals -3, and I'm going to choose to do this first equation right here, I'm going to rewrite that just with -3 instead of y. So x minus 5 times -3 is equal to 13. -5 times -3 is a positive 15. So x plus 15 equals 13. Now to get x by itself, I subtract 15 from both sides. So x is equal to -2. Now that I have an x and a y, I can come down here and say my answer is going to be -2, -3. Okay. So if we don't have graphing paper, that's one method that we can use algebra to solve these systems of equations. Now we're going to skip 4 and we're going to jump down to the elimination method and look at example 5. Okay? This method is when we have two equations and they're stacked up on top of each other. We can add or subtract these equations from each other to eliminate one of our variables. That's why it's called elimination. Okay, so what this looks like is my first step is I'm going to rewrite this top equation so that it's all lined up. Like, for example, I want my x's on top of each other. I want these pluses or minuses on top of each other. I want my y's on top of each other, and I want these numbers on top of each other. So this would look like 4x, and on this bottom equation, x and y are on the same side of my equals. So I want this y to come over to this side. So I'm going to subtract this 5y. And that's equal to 10. So all I did there is I just subtracted 5y to both sides to rewrite this equation. Now they can be stacked up on top of each other. But my next step is I want one of my variables, and let's do x in this case. You can do either, whichever's easiest for you. I want this coefficient 4 and this coefficient to be the same number but opposite sides. So basically, if this is 8, I want this to be negative 8. Okay? How I do that is I'm going to times all of this by negative 2. If I times all of this by negative 2, I'm going to end up with negative 8x plus 10y equal to negative 20. Okay? And now that I've got my two equations, these coefficients are the same, but they're opposite. I can just simply add these two equations together. So I've got 8x plus negative 8x, which just gives us 0, so the term was eliminated. Then I've got 9y plus 10y, which is going to give me 19y. Then I've got 58 plus negative 20, which is going to give me 38. Now, to get y all by itself, I divide both sides by 19, so I end up with y is equal to 2. Okay, now that I know what y is, I can take that and plug it into any of these equations up here. So I'll plug it into this top equation again. Okay, so it's going to look like 4 times x is equal to 5 times y, but I know y is 2, plus 10. Okay, well, 5 times 2 is 10, and 10 plus 10 is 20. So that's going to look like 4x equals 20. And then if I divide both sides by 4, I get x is equal to 5. Okay, so now for my answer, I need to write this as an ordered pair, x first, so 5, comma 2. And that would be how I solve this using the elimination method. So any three of these methods work. They're all acceptable. Some are easier to do with or without graphing paper. For your assignments and your test, you are allowed to use Desmos, which means you can just take these equations, plug them directly into Desmos, and you can just see where they intersect and it'll give you that answer. So in all reality, that's probably the easiest way to do it and the fastest way to do it. So that's why we're not doing too many examples right now. We're just doing these so you can see the method, but we know that you're most likely going to use Desmos all the time. Now there is a stations activity that we are going to do today, and it involves story problems, and we're going to do those as teams, and we're going to turn that in when you're done with those.